Today we're going to be talking about digital electronics. Digital electronics is a very specific field of electrical engineering that only deals with devices with two outputs, either on. Digital circuits are in everything from your microwave ovens at home to cars and automobiles, all the way up to rocket ships that carry people to the stars and beyond. However, because digital systems can only deal with two outputs, either on or off, and oftentimes have up to 8, 16, as many inputs as possible, we need to have a system to minimize the number of inputs. Luckily, there is a simple process that allows 8 inputs to be reduced down to 2 possible outputs. This is called AOI logic. AOI logic uses ICs depicted here, and more specifically the logic gates inside the ICs, such as the one on the screen now, to reduce the number of inputs from 4, 8, or 16 down to 2 different outputs. AOI logic uses 3 specific gates. Pictured here is an AND gate, the A in AOI. An AND gate will only create an output of 1 if both of the 2 inputs it's given are also 1. Also shown here is a truth table. A truth table is a table of all the possible inputs and the corresponding outputs. These are very helpful to determine what the output will be based on the inputs. Pictured here is an OR gate. An OR gate will produce an output of 1 if either of the 2 inputs given to it are 1. This is very helpful at the end of a circuit to minimize the outputs down to the last 2. And finally, pictured here is an inverter gate. An inverter gate takes the output it's given, only one output, and flips it to the opposite. To give you an example of how digital electronics can create a circuit, I have here a sample problem. So for this problem, we are creating a car alarm system. For this car alarm, the alarm will go off whenever the door is open or when the key is in the ignition and the seatbelt is not buckled. So from that problem, we can create this truth table, which takes all the variables in which the alarm will go off based on the inputs we give it. From this truth table, we can see that the alarm will go off whenever the seatbelt is not buckled and the key is in ignition or the door is open. From this truth table, we can create our circuit. As you can see in the circuit, we use one of each type of gate. The inverter gate creates the seatbelt not buckled. The AND gate creates the key in ignition, seatbelt not buckled. The OR gate creates the key in the ignition and the seatbelt not buckled or the door open. Digital electronics is a fast-growing field, and with computers and circuits becoming more and more advanced every day, AOI logic will be right there to make sure that the hardwiring of the circuits is correct and as simple as possible.